Okay, we're moving on to activity 3 of this lesson, and we're going to learn a couple of more new vocabulary words in relation to independent and dependent variables, which you already know about. So on page 415, it says, when you look for a relationship in bivariate data, often you are interested in determining whether one variable causes a change in the other variable. In this case, one variable, the explanatory variable, is designated as the independent variable, and the response variable is designated as the dependent variable. So don't get too worried or frustrated with this. The independent variable, we're also going to call it the explanatory variable, like what the information explains, independent variable. And then the dependent variable, we're going to call that the response variable, which kind of makes sense because it gives us a response. Remember, it depends on something else. So the independent variable, we're going to call the explanatory variable, and the dependent variable, the response variable. Just for now, just while we're using scatter plots. When we go back to regular graphs and linear equations, we'll go back to just calling them independent and dependent variables. So let's check out this first problem. James, who is an oceanographer, so what that means is he's someone who works in the ocean as a scientist, measuring things about the ocean, doing experiments, that sort of thing. So he's an oceanographer and he's measuring the temperature of the ocean at different depths. His results are listed in the table. So let's think of it as we normally do when we have two sets of information or have a set of information. We've got our X and our Y. So the X, and we can go ahead and answer this question, the explanatory and response variable. So the X is the independent variable. It's also now called the explanatory variable, and it is the depth of the ocean that he's at. So then let's look at the Y. So that is normally our dependent variable. So we're going to call that our response variable, and it is the temperature. Okay, so here he's got the depth at 100 feet, 200 feet, 300, all the way to 900. So at 100 feet, it's pretty warm, 76 degrees. Then 500 feet, 61. But then when you get down to his last place that he took the measurement, it was 43 degrees. So we are going to create a scatter plot using the data. So you will be doing this as I do it. Okay, so you're going to create your own scatter plot. So let's check out our variables first and our axes. Depth of water, there's our X. Temperature, there's our Y. So let's plot the points. So at 100 feet, it's 76 degrees. So I'm going to zoom in and zoom out as we do this. So 100 feet, 76 degrees. So at 200 feet, it's 73 degrees. So it looks like this is counting by twos. 40, 42, 44, 46, 48, 50. So if this is counting by twos, then this is 78, and this is 74, and this is 70. So it's at 73 degrees at 200. So it's going to be right in between here, right there, about like that. Okay, and then 300 feet is 70. Oh, here, I messed that up. Let me erase. A 300 feet is 70. Oh, 400 feet is 66. 500 feet is 61. 600 feet is 56. 700 feet is 52. 800 is 48. And 900 is 43. Okay, so there's our scatter plot. So we've got all of that done, and we have it on our graph the way it should be. So let's move on. Explain the meaning of the point 466. So 466, that means at a depth of 400 feet, or is it meters? Sorry, let me check. Oh, it is meters. The water temperature is 66 degrees. What relationship does the scatter plot show between the depth of the ocean water and the temperature of the water? So as the depth gets more, as we go further and further deep into the water, the temperature decreases, doesn't it? So let's just write that. The deeper you get in the ocean, the colder the water is. Okay, let's take a look at this note on the side. It says a linear association occurs when the points on the scatter plot seem to form a line. When the data have a distinct pattern that is not linear, it's called a nonlinear association. So this definitely seems to be like a linear association, doesn't it? Because it's going pretty steadily down. Okay, as you have experienced, scatter plots can be great tools to identify patterns in bivariate data. Sometimes these patterns or relationships are called associations. One common pattern that exists in data is when the points on a scatter plot form a linear association. In that case, the data values are arranged in such a way that as you look at the graph from left to right, you can imagine a line going through the scatter plot with most of the points being close to the line. Explain how there seems to be a linear association between the depth of the ocean water and the water temperature. There seems to be a negative slope. Decreasing line. So, as you guys write what I'm writing, please think about it. Please think about what that means, that there is a negative slope. See, if we had this line and if we got the slope and we read a graph from left to right, correct? Correct. We read from left to right. And so if it goes up, if it goes from a high value to a lower value, then we're going to have a negative slope. Okay, keep going. When two variables have a linear association, you can then determine the type of association between the two variables. The two variables have a positive association when, as the explanatory variable increases, and remember that's our x, the response variable also increases. Let me erase that. So that is our y. When the response variable decreases as the explanatory variable increases, then the two variables have a negative association. So look, this is going to be a negative association because this is the response variable and explanatory variable. And as the response variable increases or decreases, the explanatory variable increases. So this is going to have a negative association. A negative association is just like saying a negative slope. If we read from left to right and we're going down, it's going to be a negative association. Once you identify the pattern for two variables with a linear relationship, you can state the association between the two variables. When the data do not appear to have any distinct pattern, the scatter plot shows no association. So we've got three vocabulary words. We've got positive association, and it's going to look like this, just like our normal line going like that. Negative association, and that would look like a negative slope. And then no association, it would just be like if we plotted points and it looked like that. That would be no association. So we'll see some examples of that in a minute. The last question just says, what type of association exists between the depth of ocean water and the water temperature? And we already said that it was a negative association. Okay, so now let's keep going. And we're going to look at this page, number 2. This is going to be your exit ticket. So your exit ticket is number 2 and number 3. And I will look at this for grade or number 2, A and B. I will look at this when I return. So let's just go over the instructions together and then you'll be able to do it on your own. Analyze each scatter plot shown. Identify the explanatory and response variables. So you're going to need to say which one is the explanatory, which one is the response. Label them. Okay. Second, determine whether the scatter plot shows a linear association, a nonlinear association, or no association. And when there is a linear relationship, determine whether it has a positive association or a negative association. So let me give you some instructions. So number 1, label the explanatory and response variables. Number 2, linear, nonlinear, which is kind of the same as no association. Figure out. Number 3, if linear, is it a positive association or a negative association? Then finally, there's one more component. State the association in terms of the variables. So what is the relationship? State the association using the variables. So this one, A, is going to be height and weight. So you could say There is a positive association, there is a negative association, or there is no association between the height and weight of soccer players. And you would say, as the height increases, the weight increases, or as the height increases, the weight decreases, whatever the answer is. So, right here, wait time in movie attendance. So, as the time spent waiting in line increases, what happens to the movie attendance? So you're gonna use the X to state what happens to the Y. Okay, so when you are done, you're gonna tear out this page and turn it into your sub, and I will grade these when I return. Okay, exit ticket for Monday, 12/8. I need this turned in. Okay, thanks guys. See you soon. Love you.